Okay, so yes, today I wanted to talk about not only satellite observations, but ground and aircraft observations of trace gases near oil and gas observations. And this work is part of the NASA Air Quality Applied Sciences team research efforts. The PI for this work is Thompson, and there are other ACAST members that are involved in this project, including Russ Dickerson, who we heard from this morning. So recently, it has come up in our meetings with air quality managers that they are concerned with the trace gas burdens that are being released into the air near oil and gas operations. And with the projected increase in the use of natural gas for electricity, as we can see from that figure on the right there, this is quite a concern to them, and they were interested in help from the ACAST team in obtaining basically better spatial and temporal observations in methane and related trace gases near these oil and gas activities in the eastern and western U.S. And we decided to use a combination of satellite and in situ measurements to take on this venture. And as we heard from Russ Dickerson this morning, so far, the Skiamaki satellite instrument has looked into estimating relative leakage rates above a few of these shale formations in U.S. basins, and the results are pretty good, so we wanted to see what else we could get from other satellite observations. So our 4 focus regions are actually ones that we've heard quite a bit about today. We have the Appalachian Basin in the northeast, the Williston Basin in the north. We also are including formations in the south, including the Barnett Shale as well as the Eagle Ford Shale. And in the west, all of the basins that we've already heard about this morning, such as the Uintah Basin, the Denver Basin, as well as those in Wyoming, the Green River Basin and Powder River Basins. So the first place I want to start is looking at an example of the methane variability across ground sites during the deployments of the NASA Discover AQ campaigns, which took place in 2011, 2013, and 2014. And in particular, so far, we've looked at the campaigns in the San Joaquin Valley of California, the Houston area in Texas, and the Northeast Colorado this past summer. So an example of some ground observations and comparisons between 2 of the sites, we are using Penn State native trailer observations, and here on the top figures we are showing time series of carbon dioxide and methane. Methane is in the blue and carbon dioxide is the green. And so on the left is Porterville, California, where the native site was situated, and Smith Point, Texas. And so Porterville, California is near oil and gas operations, and so we expected that we would see methane and CO2 not necessarily correlated with each other, but there were occasions, as you can see there from those peaks, that they were. So what we wanted to do was look at some of the isotopic signatures from methane to discern what type of sources we are seeing these gas measurements from. And so in Porterville, California, we actually saw an isotopic signature closely related to those in the range for natural gas, but in Smith Point, where it's a site that's downwind of oil and gas observations, we actually saw concentrations where methane was greater than 2.5 ppm were actually more biogenic in origin. And so those are just an example of some of the differences between these two sites. We're actually continuing this work looking across all 4 deployments of the Penn State Native Trailer, including those that were at the Edgewood, Maryland site in 2011. Moving on to examples of some of the aircraft trace gas profile variability. So during the Discover campaign, the P3 aircraft flew over several sites several times a day, and so statistically you can look at observations of trace gases over sites and look at related gases to methane to identify possible sources in those locations. So going back to California, Discover AQ, the map on the right there shows some of the locations that the P3 flew, and 2 of which that I'm showing here are actually Bakersfield on the left and Porterville on the right. And so from top to bottom, we have methane concentrations, nitrogen dioxide concentrations, and ammonia concentrations. And these plots are in the showing the vertical distributions of the species. And when we looked at Porterville, where we saw at the ground something that looked like maybe a natural gas isotopic signature, for those values that were close to 2.5 ppm, we actually are seeing that those spikes, those those higher concentrations of methane were actually related to nearby agriculture. So if you were actually at the Porterville site, there were mangroves nearby as well as cattle farms. And so agriculture was actually the source there at Porterville, but in Bakersfield, where actually there's a high density of drilling observations, we actually find that the higher concentrations of methane are more likely due to the oil and natural gas sources there. Moving on to Colorado, this is just an example of a flight during the recent July 2014 Discover AQ campaign. These flights were in northeast Colorado, and so the figure on the left is actually showing methane to carbon monoxide ratios, and you can kind of see a difference between, say, urban pollution closer to the Denver to the south, and higher concentrations or higher methane to CO ratios in that northeast corner, Weld County, where, as we saw actually earlier today, that there's a high density of oil and gas drilling sites. And when we look at other ratios of species to methane, including ethane and benzene, we actually find that it does really pick out some of the localized sources near Platteville, Colorado, and near Greeley, Colorado, where there are drilling sites situated. And if you would like to see some more of VOC measurements during this time period, the Penn State Native Trailer was situated at the Platteville site, and there was also a NOAA trailer there taking PTRMS measurements. And so Hannah Halliday is actually going to be showing a poster this afternoon of some of the analysis she's done with ground VOC measurements, so you should take a look at that. Okay, so on to the satellite observations. And the team, the ACAS team that has taken on this venture are actually looking at a large array of satellite observations, both US-wide as well as the 4 focus regions that I addressed earlier, and which include Brad Pierce is looking at OMI nitrogen dioxide. There's other team members that are looking at formaldehyde, and for this instance, we wanted to look at methane. And so Russ Dickerson actually showed this morning some methane observations from the Skiomaki instrument. Here I'm actually going to show observations from the tropospheric emission spectrometer, the TESS instrument. And with TESS, it's sensitive in the infrared part of the spectrum, but newer versions of the retrieved methane product actually show that it has sensitivity in the mid-troposphere. So we're looking at values that are representative of the free troposphere over these regions. And we wanted to look at this mostly to see what it looked like, what methane looked like over these regions, as well as downwind of these regions where maybe ground and aircraft observations are actually sparse. So the top figure shows 2006 to 2008 means binned at ½ degree. And those red boxes there are just showing the 4 focus regions that I'll talk about in a minute. Zoomed in, and then on the bottom is actually methane concentrations for the time period of 2009 to 2011, and you can clearly see that there was a change in methane during that 5-year time period. And if we zoom in into those regions, the first one is looking at northern and western U.S. basins. And we see the figure on the left is the methane concentrations. The figure on the right is actually showing methane anomalies. So this is the difference between the concentration test retrieved and the background value for this region in parts per billion. And so the numbers there are just kind of indicating some of the basins that were talked about today. And I just want to point out some of the positive methane anomalies that we're seeing there for the Green River Basin as well as the Powder River Basin. This is Texas. So Texas, we actually don't see as good of a signal, and that's probably most likely due to the fact that it's a column measurement, but we do still see positive anomalies in north and south parts of the Eagle Ford Formation, which is similar to what Russ showed, or what the Skiomaki results show for the Eagle Ford Formation. And for the Marcellus is still a big question mark for us. But we are working on this, and there are upcoming aircraft campaigns to help validate the satellite observations. And this is just a summary of some of our results. And I've already pointed out that there were the largest changes that we saw were in the Green River Basin and the Powder River Basin. And also on the right-hand side there, which shows that change during that 5-year time period of methane anomalies, we still see that the Appalachian Basin had positive methane anomalies. So I will leave this here. This is our highlights from this work, and I just want to say that this is a combined ground, aircraft, and satellite observation research work. We are going to extend this work into looking at satellite trends, and to help with the air quality managers, we're looking into comparisons with emissions estimates. So I'll stop there.
I think we have a question for maybe one question. Time for one question.
I think it would be very useful to look at errors as methane anomalies, given the scale of the area. You're not looking at a very tiny
Right. Yes, that and also we are actually thinking about using YASI, which has a little bit better spectral sensitivity to methane. So that's another option to deal with basically the temporal and spatial issues that tests might have. So.